Okay, good. We're on page 4. This is 9 through 12 of our lesson 2 practice. So here on this one, you should have done split the middle. There are 3 terms here, so it's definitely a split the middle problem. So we do 2 times negative 12, which is negative 24. And then we find all of the different combinations to get to negative 24. So we could do 6 and 4, 8 and 3, 12 and 2, 24 and 1. It looks like since we have a negative 24, we're going to have to make one of our numbers negative, and we want a positive 5. So if I do 8 and negative 3, that would get me to a positive 5. So I'm going to split my middle term into 8x minus 3x, bring down my negative 12 and bring down my 2x squared. And then I can group. Here we can divide out a 2x. So we're left with x plus 4. And in our second set, we can divide out a negative 3. And then we're left with x plus 4. You want your parentheses to be the same, of course. And then your other part of your answer comes from your GCFs. Put those together for your second part. So here, solve this one using the zero product rule. So we get a negative 4 for one of our zeros. And then our 2x minus 3. We add the 3 over, I'm out of room there, and then I would divide by 2. So we end up with 3 halves. Okay, we'll put this into Desmos. Okay. All right, so it looks like we have negative 4 and 1.5, which is the same thing as 3 halves. And then our turning point is the same as our vertex, which is negative 1.25, negative 15.125. To have a little bit more room. Okay. And then our range will be from lowest to highest y values. Well, this goes to positive infinity. So we would say y is greater than or equal to negative 15.125, since that's our lowest y value. Okay, number 10. So if you look at this one, this could be difference of squares. However, 2 is not a perfect square. So we're going to go ahead and GCF. And we can divide out a 2x from both terms. So we're left with 1 minus 2x inside. Take both parts and set those equal to 0. So we end up with x equals 0 and this one here would end up being x equals positive 1/2 because we have a negative divided by a negative. Okay, so our 2 zeros are 0 and 1.5, which we nailed that. The maximum value is the highest y value, which is 0.25, and then our domain, even though it's pointing down, it's going to go infinitely to the left and infinitely to the right. So this is still negative infinity to positive infinity, or all real numbers. Okay, number 11. Here it says circle 2. So there's two different methods we're going to use here. If we look down here, we know that we can do a GCF. So we're going to go ahead and GCF and do 2. So we're left with x squared minus 9. And that x squared minus 9 on the inside is actually a difference of squares problem. So if we take the square root of both terms, the square root of x squared is x, the square root of 9 is 3, one of them is positive and one of them is negative. We don't really worry about the 2 since it doesn't have an x, so we'll have our x plus 3 and our x minus 3 to solve. So we end up with negative 3 and positive 3. Okay, put this in. Okay. So our turning point is down here at negative 18. So our range will be from negative 18 and greater. So y is greater than or equal to negative 18. And number 12, this one says choose 2 as well. So we always check GCF, and we definitely can pull out 2 as our GCF here. So we're left with x squared minus x minus 30. And then on the inside, we can do a split the middle problem with that, except for this is one of those quick scenarios where there's a 1 in front of the x squared now. So we want to find two terms that multiply to negative 30, but add to negative 1. Well, we can do 6 and 5 if we make the 6 negative. So we have x minus 6 and x plus 5. Set them both equal to 0. We get positive 6 and negative 5. There we go, negative 5 and 6. Our vertex is 0.5, negative 60.5. Oops. I'm going to zoom in, and our y-intercept is 0, negative 60.